Hi, this is my name is Chris Carrigan. I'm the expert data advisor to Use My Data, and this is the latest of one of our regular sessions, education sessions for our members. This is on the topic of artificial intelligence. So I'll just put my screen up. We get these suggestions for our educational sessions come all from our members, either in emails or comments they make or other things. So all the topic areas come from people. And this was one of the ones that's come up lots and lots and lots of time. What is artificial intelligence? So we decided to run this quick education session on artificial intelligence. So what I ideally want to do is, it won't go into huge amounts of detail, but it should give you enough information, enough background to have a bit more understanding about what AI is and what machine learning is as well. We'll cover that as well, with some examples of where some of the reality of where it is within healthcare, how it's being used, and some of the opportunities and some of the things to think about as a member of the public. So let's crack on. So first thing to mention is the webinar that we ran a couple of weeks ago around artificial intelligence. What's the reality? After you've been through this session, it's probably a good idea to watch that recording, because we got some really sharp insights from people working in different areas of artificial intelligence to explore some of the details about what we'll cover here. That's available on the Use My Data website, which is usemydata.org.uk, and you can follow the links to the events page or the homepage. It might be on the homepage still. It's worth watching. So today we're just going to go through some of the introductions to that. So I want to go through the concept of big data, which you might have heard is a good phrase that's going around at the minute. Artificial intelligence, machine learning. I also want to cover algorithms, which is to a degree how machine learning, how artificial intelligence actually works, and what those are, because you may hear some of the algorithms mentioned in some of your conversations. And then things you might want to be helpful when you're watching the webinar back, or that you may find useful in various other things, such as reading articles in newspapers, including how it's affecting us now, how it's affecting the NHS, the healthcare, and some areas around risks and safeguards and unknowns that you might want to consider. So let's start. Artificial intelligence. Well, you can read it there. It is a general term. It's been used quite widely to cover lots of different things, but essentially it means software, computers that can mimic how human thinks or seems to think. So it's basically trying to replicate the thinking process of a human. Somebody at the webinar mentioned the Turing test, and the Turing test is around how well a computer can mimic the actions of a human. And that's what AI is. It's essentially mimicking human cognition or perception. To operate effectively, artificial intelligence needs lots and lots of data, often called big data. Again, big data is a generic term. One person's big data is another person's really, really small data. So it's a relative concept. But what big data does, it brings together quite complicated sets of data in one place. And artificial intelligence allows you to sift through all that data and to make more sense of it than a human could. Mostly because of time, I have to say. It's virtually impossible for a human to sift through lots of data, but a machine can do it, and it uses artificial intelligence as a concept to run through all that data and try and make sense of it. Big data can be generated from all sorts of different places. The idea of big data, it's generated really, really quickly. So there's more and more and more big data being generated. So from 4 minutes ago when we started this presentation, there's huge amounts of data that's been generated in the world, new data, including data that's been generated about inside the NHS, about us, and by us. So it's generated very rapidly. And the data comes from lots and lots of different places. So if you think about how we interact with the world, you know, I'm talking now, we're recording this, that's data. You've got your own little handheld devices, you've got your portable computers, you've got your phones, you've got interactions you make with the NHS, you've got Fitbits, or your banking applications. Everything you do in the world these days relies on data. And big data is generally meant to encompass all those different things. The question comes about where you draw the boundary about what your interest in big data is. And today is going to be largely about the health elements of big data. The other key point about big data is it's structured, semi-structured, and unstructured. So computers work very well with coded data, ones, twos, noughts, ones, specific fields of data where data is coded so it's easy for computers to count. Where data is unstructured, such as in free text reports, where you would complete a patient-reported outcome survey, where you put your free text answers in the end, all that is unstructured data. There's huge amounts we generate in our lives, but there's loads and loads which are generated throughout the NHS and beyond of unstructured data that computers have found very, very difficult, if not impossible, to analyze. So big data includes all that unstructured data as well. And you need new techniques to look at that. So let me give you my brief Ladybird book guide to what I think big data is. So here's a book. And if I was to ask you, oh, what's that book about? You could relatively easily open the front cover, or even read the title from the front, but open the front cover, read the introduction, or go back to the last page if you like me and read the last page of the book first. And you could very quickly say what that book's about. That's it. There's lots of data in there, but to ask a simple question of it, what's the book about, is relatively easy. If you've got a stack of books, there are different sort of questions you can ask from the stack of books. So you could say, here's a pile of books, could you find me the dictionary? And you could go through those, look at the titles, you could say, no, 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 yes, oh, that's the dictionary. So again, that's now becoming bigger data, but you can ask slightly different questions of it. But analyzing all that would become quite difficult. But you can do certain things like, where's the dictionary? If you extend that out to another level, where you get a library, where there are, sorry, we're all old enough to remember libraries, I hope, where you get lots of books stacked in shelves. And the question there you might be able to ask is, well, can you find me books about travel? And what the library does here to make that easier for you is it sorts them into different compartments, different shelves. You can see the labels on the shelves, which would label what the books are about. So you could find the right shelf and you could find all the books which are about travel. Indeed, to help you do that, you often find old style library cards. This is going back a bit. This is now all computerized, but library cards very simply say one card for each of the book in the library with some very small bits of information, very structured information, like the author, like a code. The top right is probably the place in the library where it sits. You've got the author's, the title of the book, you've got the date it was published, and one or two other things, but very, very limited information. But that's essentially what a computer would call an index. In fact, they were called index cards. And you can use those cards to go and find the book, but that's it. Nothing else. You couldn't figure out what's in the book without going away and reading it, which would take you a long, long time. So there are different ways that we as humans have structured and compartmentalized data to make it easy to find, and a library is a good example. What you can't ask from any of this is, well, what's it like to travel in Canada? Now, the library holds loads of travel books. It loads loads of books about Canada. It will hold loads of personal stories of people who traveled around Canada, perhaps parts of their individual biographies and other things. But what you can't do is ask yourself, what can I find out in this library that tells me what's it like, what's the consensus of views about traveling around Canada? Now, you could do it. You could read every book in the library, and you could make your own notes. You could try and make sense of those to produce an answer. But in reality, you will never have enough time in your life to do that. And you multiply that simple question 1 million times, obviously, we're not enough people in the world to answer questions like that. And that's where artificial intelligence and machine learning might be able to answer such questions in the future. So what AI can do, it can harness all that big data. It can take every bit of information that's in all the library books, in all the libraries. But what we can use it for in health data is to try and identify diseases more quickly, in particular to speed up the way diagnostics happen, to spot disease at an earlier stage, perhaps with particular symptoms. And you could also use it for monitoring patients through things like apps where the AI can watch what's happening with your heartbeat, watch what happened with your activity, and it could give you prompts or could monitor what's happening with you in real life. Now, all that is possible, but, and it's a big but, you need a huge amount of computing power to be able to do any of those things. Even my simple question, what's the consensus of views about traveling in Canada, would take a fair amount of computing power to go through. Now, computers are becoming more powerful every day. There's an exponential growth curve that was used to be quoted many years ago about the doubling rate of computer power, and it continues to increase. So the capacity to compute, power to compute, doesn't really seem to be a problem, frankly. Nor does the amount of data that artificial intelligence needs. We know there's huge amounts of data out there. So the first few things that artificial intelligence needs to run are actually ticked off. We've got the computing power, and we're getting even more day by day. We've got the data's already there. Largely it's available, and largely it can be linked together and be made available through an artificial intelligence algorithm to make sense of. The questions really are, well, is any of this darn stuff going to work? Can we actually do anything with this? Or are we just going to get bland, benign things that we knew already? Or is machine learning and artificial intelligence actually going to make a difference? And can these machine learning algorithms, which don't just mimic human behavior, they improve on human behavior, they make their own decisions, they follow their own thought patterns, can those sort of things, like techniques, make discoveries that we either couldn't do or wouldn't have time to do? And that's really where the challenges are. And again, if you watch the webinar, the more detailed version of this, you'll see some good examples of where that's happened and some of the realities of the difficulties of those things. So I mentioned machine learning. This is how the computer system develops its intelligence. So rather than the Turing test just mimicking human behavior, this is generating its own particular behaviors based on what it learns. It's a completely different science from traditional ways of working. So the machine learning algorithms, there's that word algorithm, we'll come back to that in a second, build a model based on all this data that's out there, and they use that model to make predictions or decisions. But nobody's actually programmed the computer to do that. It's learned it itself. It's given some associations between data, and it just goes and looks through the data, finds patterns, finds other associations, finds links, many which will go to nowhere with blind alleys, but some which it finds could be really useful, could be useful insights into things we could not known before. And in particular, machine learning can do things which traditional algorithms simply couldn't do. So this is completely new science. So let me give you an example. So when I was growing up in the IT world, this is an algorithm. And this is a particular query language, which most databases for the past 30, 40 years have used, called SQL, structured query language. And there are variants of it and there are various other things, but essentially it demonstrates what a computer needs to be told by way of an algorithm. This is an algorithm to go and do something. And what this is saying with my library analogy is, okay, I want you to look in the library index, that's where you're going to get things from, and I want you to find the bookcase, the shelf and location, where the book code is X123. And that is an algorithm. And computers work really well with that stuff because it's simple, it's precise, and it's working with coded data. So where the book code in this case is equal to X123. So that's an old style, very traditional way of working, a traditional algorithm. And that works really well. So the bulk of the computer systems in the world use this all the time. If you looked at taking to the next step, well, what's a different way of working? This is a different type of algorithm. This is what you would call an unstructured algorithm, based on what people say about Canada. Where would a good place for an older gentleman to visit when he only has £1,000 to spend because he's from Yorkshire and he's very tight with his money? So that's an algorithm. It's a question, but it's phrased in a completely different way than the one above. So the one above is traditional ways of telling a computer to go and find something. Please give me the answer to this question. The one below is what we really like to say to computer systems. Based on what people say about Canada, where would a good place for me to go to visit when I've got £1,000 to spend? Wouldn't it be ideal if we could just ask computers to sift through all the data in the world to answer that question for me? And that is where machine learning comes in. That's the way machine learning operates. Those are the sort of questions that machine learning is designed to try and answer. So what's the reality? Because that's all fine and dandy and lovely, but what's the reality around some of this stuff? Well, you'll have seen in the newspapers, and I put these slides together about 3 weeks ago now, and there's been more and more and more since about artificial intelligence in the news, not least with all the big internet search providers like Google implementing artificial intelligence algorithms into their search mechanisms now. But one of the most prominent that hit the news is a thing called ChatGPT. And this is a screen grab from the ChatGPT website. It's on the web. You can go and register, and then you can get access to the ChatGPT itself. And this is an artificial intelligence engine, if you like. It's designed to answer really tricky questions, and you can go and try it. You register with your email address, they send you a link, and go and try it. So I did. But if you look on the website, it gives you some examples of what the ChatGPT is about, what artificial intelligence can do these days. And this is an example, again, just a screen grab from the website, where they'd said, oh, we asked ChatGPT to explain itself to other people in the stock market. And it showed you what the answer it came up with was, which is several pages long. You don't really need to read it, but it comes out as free text, as a narrative, a description rather than list. So it immediately looks far more intuitive to people when they read it. It feels more intelligent as an answer. And if you go on to page 2, there's other things as well. So I thought, this is interesting. I've got to explain AI to you guys. Maybe I should just ask ChatGPT how I should do it. So I did. So I typed in, before I put this presentation together, how should I explain AI to people? And he gave me an answer. And actually, the answer wasn't bad. It certainly wasn't wrong. It may not have been complete. It wasn't particularly focused on our needs and how I might have described things, but it's quite a comprehensive, sensible answer. It feels intuitively pretty intelligent. And this has all been derived from computer systems looking at vast amounts of data and putting associations together. And it puts the answers to my question, how should I explain AI to people, together on the fly. It does it there and then. It's not got an answer pre-written for itself. So I thought it was quite a smart piece of work. And again, it goes on to 1 or 2 pages. And interestingly, on the second page of the answer, because it was a long answer, it pulled up some other things, including doctors diagnosing diseases in the middle of the page. But then it also highlighted ethical concerns, and it gave some examples, such as privacy and bias and other things around changing the working world. Are our jobs going to disappear? We've heard that over many generations with different technologies coming on, but it flagged those up as well. So, well, what do you think are those ethical concerns? And there's some examples here. If you want more detail on these, we've covered some of these in the webinar as well, in a bit more detail with some of the other experts. But you know, how concerned should we be? So artificial intelligence has appeared in lots of articles about particular aspects of life. So facial recognition was one, which was quite early on, where if you look at the CCTV cameras around train stations, for instance, they're watching things all the time. They're recording what's happening, and they record the video imaging of the footage onto a big hard drive, a big floppy disk somewhere, and that gets recorded. In the same way that if you've got your Skybox at home, you can press record and record the program for you, and that's there as a record. And in days of old, if a crime had taken place, the police might go to the people who hold the video recordings and say, could you show me the recording from 3rd of January at 4 o'clock in the afternoon to see if they can spot a crime being committed. That's how that data has traditionally been used. But these days, because artificial intelligence and machine learning runs in real time, it runs there and then as we speak, the concept of real-time facial recognition, being able to spot somebody's face in the crowd as they're walking through the station, became real. And there's been lots of articles about this in quite recent years about how that technology is developed and how it's been used or potentially misused. You know, how would we feel about our faces being tracked around a railway station or around the streets of London or Sheffield or wherever? Because the capability to do that with artificial intelligence, and cameras are very good these days, and there are so many of them, that becomes very real. So there's a whole set of new ethical questions which come up around the use of AI. The other key one that's worth thinking about is bias. So we talked about the algorithms, we talked about the big data, but if the answer will only ever be as good as the data that the algorithms can work upon. So if my question about what's the best place to go in Canada if I'm traveling is based on 3 books, it'll give you a particular answer. If those 3 books don't include the western part of Canada, I'll only get a biased answer. And it's the same with data about people, and it's particularly the same with data about people and health. So if the big data algorithms, the machine learning algorithms, are using data which doesn't include subsets of the population, you'll get answers which don't reflect subsets of the population. And we've certainly seen elements of that where some of the early facial recognition software didn't work on people with black skin because the data had only been trained, or the algorithms had only been trained on people with white skin. And that's a very simple example of bias, but the bias can exist in many different aspects. So the bias is based on how good the data is in the first place. The algorithm needs to train itself. If it's only training on half of what it exists in the world, it won't give you full answers, and that's where bias can be introduced. Similarly with inequalities, if you don't address those bias, you could, in theory, miss out the needs of lots of the population, might not be able to spot things within that population because they're not represented in the data. The other key one for me is, okay, all this is possible, but just because it is possible, does it mean that we actually should be doing these sort of things? If we can do it, should we actually be doing it? And that's definitely something which society is going to have to grapple with. I don't have an answer to that. I'm not sure society does yet, but there are various different groups around ethics, and we've got the Centre for Data Ethics in this country that looks at things like that. It's a real problem. Another concern is about the level of control. So if you go and see your GP today, if you get yourself an appointment, the GP has got in front of him or her a computer system, which includes our medical records, but it also has various other bits of things which can pop up on the screen, which would suggest certain actions that the GP might want to offer to you as a patient. And those things are largely called decision support. And the key word there is support. So computer systems for a while now have been able to offer supporting suggestions to our medical professionals to say, maybe you should consider this, or maybe a course of action could be this. But the decision is always made by, in our case, the health professional. Brenda's shaking her head. We'll come back to that in a minute, Brenda.
Not convinced.
Right.
Not convinced.
But which demonstrates it's a really interesting question, because when do you move from that advisory role, particularly with artificial intelligence, which is becoming more and more and more face value properly intelligent? What happens when you begin to move from the advice to the decision-making process? And that is a significant area of concern, because if I go to my GP and they say, oh yeah, I've looked at your record, take this tablet, you'll be great, and I get a really adverse impact of that, I become ill because of that, I could go back to my GP and say, was that the right thing? Now, they may come back and say, well, yeah, it's a really rare condition, or we've not seen it before, but it was the right suggestion I made. But I can go and ask the GP that. If an artificial intelligence algorithm says, yep, go away, Chris, take this tablet, you'll be fine, and I'm not fine, who do I go back and query about it? Who makes the wrong decision there? It's not the doctor, because if the computer system, the algorithm has decided that's the right course of action, do I criticize the doctor? Do I go back to the software developer, the company who developed it, the hospital that's running it, or what? So there's a whole set of different questions we need to answer about what happens when we move from artificial intelligence and machine learning algorithms giving advice to being able to decide on certain things. And that is a particular conundrum for the NHS. The final couple of points around de-skilling the workforce. I think every time we've had any element of technological advance, there's always the question about de-skilling the workforce. And it's a real thing. Society has changed over time because technology has moved on and workforce skills have moved from one particular requirement to another. There's a real risk or something we need to be aware of about what artificial intelligence and machine learning could do, which could, in fact, de-skill the workforce. So we become so reliant on it, we don't need as many skilled people to make decisions. And then finally, how to regulate all this. And that's a task which is challenging many people in government and in specialist agencies such as the Centre for Data Ethics, as I mentioned, and other bodies which are looking at ethical and appropriate use of artificial intelligence and machine learning in the world, in healthcare, and in society. So those are some of the concerns. And I could rattle off others, but I thought, no, let's go to two quite different people. One is Stephen Hawking, one is Elon Musk, and both of them have got their own concerns about artificial intelligence. Now, the Stephen Hawking one was a while ago. Could spell the end of the human race. Now, you could say that was a a title for a presentation, but he raised some legitimate concerns about the risks of artificial intelligence, not least of which the ones we've seen on the previous page. And then more recently, Elon Musk, slightly different language, AI scares the hell out of me, and you can read the rest of it. And the rate of improvement is exponential. I think that last point is really important. Machine learning and artificial intelligence, once it gets started, once it learns for itself, it learns faster and faster and faster and faster. And there's a sort of an inevitability that it may not stop. And those are the things we need to be quite cautious of in terms of how we understand what the artificial intelligence is telling us in terms of an answer. So it wasn't just me. The other point about AI is, as I mentioned, it may not always get it right. And I've got an example which is nothing to do with healthcare. It's to do with the wacky world of Formula One racing, into which each of these teams plugs in millions and millions of pounds every year to develop racing cars that go fast around a track. They do that within a set of rules. The rules are defined by the governing body. And each of the Formula One teams is given exactly the same rules, exactly the same constraints, and exactly the same regulations within which they must work. And what each of the teams has done over time is they developed large computing power, artificial intelligence and machine learning algorithms to say, calculate the best aerodynamics for a racing car based on those exact same set of rules. And what you'll see here in the yellow circles are two different Formula One cars, two different teams, and completely different answers they've come up with. The one on the right-hand side is a racing team called Red Bull, and they've got a sort of a bulbous thing where the word Oracle appears. And on the left-hand side is Mercedes, and they have nothing there. It's a very flat aerodynamic structure. And that was both those were developed by artificial intelligence, machine learning algorithms, and come up with very, very different answers. And hey, the one on the right goes a lot faster than the one on the left. The one on the left are now beginning to change their car. So machine learning, given the same rules, the same regulations, the same constraints, come up with very, very different answers. So what about AI in healthcare? And there's a few examples I just listed out here. Some of this was covered in the webinar, actually, so it's definitely worth watching the webinar afterwards. But we looked at, well, are there some real life examples of where artificial intelligence has actually made a difference in the NHS, rather than the rhetoric and the promises? And there are some growing examples out there. You can see some on there around strokes, where atrial fibrillation mechanism with artificial intelligence and machine learning saw the annual number of strokes fell by 22%, and you can see that the other examples down there as well. All these are on the internet. They're all freely available. You can read up on them if you want. But these were just some examples which I found, which were sort of demonstrating to me quite different ways of using AI. The third one is interesting because it turns a camera, a digital image, into a tool. So rather than looking at data, camera could detect clinical images, and the artificial intelligence and machine learning would work on the image, like facial recognition, to look for certain things with early kidney disease. So there are lots of different ways that AI is being used in the NHS today, or beginning to be used. I think it's still really at a very early stage. I mentioned AI in the news. These were some relatively recent ones. I said I put this set of slides together a couple of weeks ago now. But if you look in the press about AI and healthcare, you can see some articles which try to demonstrate how this information is sifting out to the public, how the public is hearing about artificial intelligence and AI. They're not awfully enthusing. They don't immediately grab you and say, "Oh, I want to spend lots of time reading on that." But so the way that AI is presented in the media tends to be largely around robots and people taking over the world and Terminator, rather than the reality, which is what you're seeing here, which appears to be less face value, less interesting, but is now beginning to be sifting out to people. And the bottom point was something which was the headline of one article: building the largest healthcare data platform in the world. That's essentially what the NHS is. If you could encapsulate and bring together all the data the NHS has, which frankly it can't at the moment, even for AI, but if you could bring that data and make it viewable to machine learning, you could potentially generate whole new sets of insights. So that's where the potential is for the NHS. So just to summarize some of these things up, some practical things for you to consider. Regulatory framework is absolutely still developing. This is all still really new, nerdy stuff. And it's going to be a long time developing, but it comes very, very quickly if we're not careful. And if you go down a blind alley, you can go down some very rapid blind alleys very quickly. There's a whole question about balancing privacy and innovation. We want our privacy to be maintained, but AI and machine learning and relies on big data, and big data has very, very detailed information about us and about health conditions and about our life conditions. So to be truly innovative, you'd say you need more and more data, but the more data you give to somebody, the less privacy you retain. So that's a balance we're going to have to strike very carefully. And then finally, the point about how you decide to listen. As I said, the Mercedes and Red Bull example on Formula One could be replicated in healthcare. If one artificial intelligence algorithm is saying, this is what you should do versus this is what you should do, how do you equate one versus the other? Where does that arbitration sit? You could ask for a third opinion from your clinician, but they'd probably go and run an artificial intelligence algorithm and be advised by that. So there's a few things to consider as we move forward. And again, some of those are talked about in the webinar. Other ones, we've heard about Dr. Google. People now, rather than going to doctors, are just Googling what their condition is. And you could argue that, well, there's some real potential there to be more refined in terms of the clinical advice that Google could give to you and I when we ask them a question. But are we really ready for this? The decision versus support is a real tricky one. And finally, trust, particularly around data. If an AI decision turns out to be wrong, think of the damage to the reputation of AI that could happen and the potential limitations that might put on things. So there's some real issues around how this is developing, and it's moving very quickly. I guarantee you'll read something in the media next week, which will be quite different about AI, and you'll read something the week after, and the week after. So it's going to continue to come at us now. It's definitely going to change things. There's no doubt it's changing things already. It's changing the way you interact with the world and through the internet with Google searches and things, an example. It's changing the way the NHS is thinking about how it wants to use its data. But this is, for me, it's going to take a long time to work its way through to get some real benefits and to do it properly. And it's going to need a real good conversation, open conversation between the experts and the public about where the benefits sit and where our balance of comfort sits in this world. And my last point was about, I mentioned again, the webinar recording. If you want to look at some of these things in more detail and hear from people who know more about it than I do, some people have used AI, some people are leading the AI on the technical front, and a patient who's been involved in AI projects, the webinar's a good place to watch. It's a good recording. See. So one last thing. The other thing I tested with ChatGPT was my other question. Based on what people say about Canada, where would a good place for an older gentleman to visit, like me, when he only has £1,000 to spend because he's from Yorkshire? And I tried this into ChatGPT. This is my question. And it gave me some quite neat answers, which on the face of it look pretty good. So these are elements of real life where we could begin to use it. So this is just a real life example of where I used it just to test things out. So I'll finish there. I'm going to stop sharing the screen. And yeah, well, any questions or thoughts or comments or things that weren't clear?
Yeah.
Brenda, you got your hand up. Go for it.
I've got some concerns. I don't know whether you can help with this, but concerns of where probably machine learning rather than AI in general is coming up with solutions that it apparently can't explain. It seems to me very dangerous. I mean, if you've got a flow chart which says, you know, you go to a GP and if you've got this symptom, that symptom, he'll try that. You might be wrong, but at least if you go back and say, this hasn't worked, he knows he can go back on it and look at it. And you've got some responsibility. It's still the GP's responsibility.
Yeah.
But, you know, how does this machine learning, how could it be controlled so that it had to explain its logic all the way along?
Yeah, it's a really good point. So let me give you an analogy. So if you're a researcher needing to do some research which needs health data, then you largely go through a process of ethics. You apply for that access to the health data. The health data is given to you. You do your research. You produce all your tables of numbers, and then you publish in the journal after it's been peer reviewed. You need to retain all that evidence of where you made those assumptions from in your data. That's kept by the research team. So if anybody questions it afterwards, you can always go back and relook at the data in exactly the same state as it was to say, did you make the right interpretations? That's traditionally how researchers work for many years. The artificial and machine learning world is quite different. Because the data is changing so fast and it's increasing so much, there's a danger that the data is different from one day to the next. So if you make a decision based on data on day one, when you come to day 5, you might make a different decision, for instance, because things have changed, or the algorithms improve because the algorithm itself learns and learns and learns. So that's one of the real problems about how replicable a particular decision or advice is on one day. Further on down the line, will you come up with the same answer? I don't have any smart answers to that. But the traditional way of doing it is to keep a copy of the data and the algorithms as it was to begin to replicate it, and equally to keep a copy of the algorithm. You remember my select star from table where code is this? Click to keep that separate in a file and don't change that. So people can always test my logic, they can test the data, and they can test my assumptions. That's how researchers worked. Now, all those 3 things become really difficult in machine learning and artificial intelligence because the algorithm will have changed and developed, the data will have changed and developed, and the assumptions people make can therefore change and develop as well. So there are some things you can do in terms of keeping copies of things and keeping notes of things, and the algorithm would list itself out at a particular point in time in simplistic terms. It'll keep a record of itself as it was. But because the algorithms can be so complex, really difficult for somebody to check through and make sense of it. You know, the algorithm might be as complex as the whole volume of books in the library. We've already seen to read all the books in the library would take a person a long time. So the ability to check some of these things will become a really fascinating topic for technologists. But you're right, Brenda, it's a real problem.
Can you actually ask the system to print, or not print out particularly, but to detail its algorithm to tell you how it got there, which steps it went through?
Yeah, so the algorithms they can all be listed. They can detail what the algorithm is, but they can become highly complex. So it's often not easy to sift out what that means to go and check it, for instance.
To go back to an analogy for that, you know, using SQL, you were doing a payroll. I mean, payroll can have lots of different rates of pay and goodness knows what, but you can it's still documented how it got there.
Yes.
But from what I've heard of machine learning, it's kind of, well, let me just say where I'm coming from here. I'm a lay member of a research ethics committee, which makes me which is where I came into interest in this. But I get the impression that researchers say, oh, it's machine learning, it learns on its own, and almost implies you don't need to know, and we're not going to tell you how the machine got there because we don't know.
Yeah, well, that's one of the things that where the Centre for Data Ethics I mentioned a few times now is getting involved with, to say how would you demonstrate that what you have done is ethical, is correct, and can be challenged. So that's their job, is to try and nail some of those things down. So an algorithm is an algorithm. It's still just a set of steps and thought processes that go through. My simple SQL algorithm is very easy for me to write, and it's very easy for me to understand, for anybody else to understand. One which is much more complex would take longer, but it can absolutely be defined at a point in time. Yeah.
Because it's just that sometimes people said almost as if we don't know how it does it, particularly images. It's got, you know, as if it's got this way of learning that it can't be explained, and that really worries me. Really does. And the other thing that worries me, I was thinking of a fictional example the other day. Say somebody says, got some stream water that is really good and it helps you lose weight, and they come out with this analysis, and it's, yes, they've done the average, and the average person in this area has lost so much weight. And then, but if it was through people doing the research, say somebody'd noticed that there's a maternity hospital nearby, you know, so, you know, just to make it. But to me, it's people looking at the data and thinking, hang on, that might be because this has happened or that happened. Whereas the AI might not get that particular data, or might not think that's relevant.
Yeah, and there's a few arguments to that. One is, first of all, people make mistakes. You know, we're very fallible. The second is, well, if you'd just given all that data into the machine learning algorithm, it could have spotted that association, which is debatable. But yeah, I don't know. I don't have the answers to these things, but the example you gave is quite correct. If the algorithm doesn't see certain things, or doesn't understand certain constraints or conditions, like the fact you've got maternity unit there, it will miss things. And that's one of the arguments that technologists have about, well, this will only work properly if you give it more and more and more and more and more data. And that's where some of the privacy and the ethical concerns, that balance needs to sit for me.
Yeah.
It's a tricky one.
Thank you. Yeah.
Other points, questions, you can either use your electronic hand or you could just speak, or you can wave at me if you've got your camera on, whichever you prefer. Helen, go for it.
Thank you. When you were talking about bias, I was thinking about research that often is all based on English language publications and English language data. Does AI with machine learning, would it cope with data in different languages and be able to process that? Because if you've got, I don't know, a relatively uncommon condition, that it's actually hard to actually produce something that's meaningful from your country's population, let's say. I mean, it might not be a particularly good example. If you reached out globally and machine learning could cope with different language inputs and bring that together, that would be very valuable in terms of reducing bias. But would that be possible?
Yeah, that's a really good question, and that's exactly the question that got asked in the webinar. So I'll give you a quick précis of it. The answer is yes. So AI and machine learning techniques is being developed across the world, including working with different languages and different cultures. There's another part of science called natural language processing, which looks at the construct of any particular language and turns it into something which is a bit more computable for machine learning. So that also gets bedded in the mix. But there definitely AI, machine learning, and natural language processing goes on all around the world using different basic indigenous languages. The potential to bring those together, I think, is there, but I don't think it's been done yet. As I said, a lot of this is very, very early days. And to a degree, it's people trying to find a solution, looking for a problem looking for a solution, one of those two. But it's very early days. But yeah, it does happen elsewhere in the world, but I'm not aware that there are things that have made real insights into using different languages from different countries. It's going to happen. It might be better to watch the more sensible and intelligible answer that the AI expert called John Rigg gave on the webinar, and then you can come back to say, Chris, you're a Muppet. Well, that's the best I could do here. This is meant to be a grounding for AI.
That's my kind of level. Yeah. Thank you.
That's a good point. Other questions or concerns or things that were confusing to understand? Yep, go Raymond.
Could you just talk a little bit more about the false positives and false negatives and the implications of those? Because, I mean, if you make a decision about an F1 car, if 9 out of the 10 teams build it and 9 get it right and 1 get it wrong, that's just money, that's a consequence. But if you introduce AI into medicine and trials in particular, what are the consequences, and how ethically can we manage those potential consequences for false positives or false negatives?
Yeah. It's a really tricky one. To a degree, you could say you need to run the same rigor with any test or research or trial using machine learning techniques as you would with traditional manual techniques. So the same principles would need to apply. It has to be open. You've got to figure out how the results can be tested. Yeah, I mean, false positive, false negatives. Part of the thing that we've not done very well in the past with the health data generally, ignoring AI and machine learning, is using it to track long-term health conditions of people many, many years after a particular health intervention took place. So 40 years ago, people were given chest irradiation for particular forms of cancer treatment. Later on in life had cardiovascular effects, which weren't known at the time, weren't seen at the time, but were only spotted in the data. And they were spotted by researchers looking at patterns in data. And the way they did that is they came up with a hypothesis that said, well, surely if you irradiate in the body near the heart, it can do some damage to the heart later on in life. And that was their hypothesis. And then they used the data to test that hypothesis. So that's the way that traditional research would happen. The thing with machine learning and artificial intelligence is there's an arm that says, well, just let it go. Just press the button, let it find stuff. And you're going to find lots of false positives. You're going to find lots of false negatives. The trick is how on earth you sift one from the other. And for me, that's going to have to be around manual intervention checks, lots of regulation, I suspect, will fit around this, because you shouldn't just trust what one machine learning algorithm says, in the same way that you don't trust what one researcher says. That's what peer review is about. You might find a situation where the only way of peer reviewing one algorithm is to use 3 or 4 other algorithms to try and do the same thing. I don't know. I think that's one possibility that's been mooted, but it does feel a bit woolly when technologists are driving this rather than ethicists, I have to say. So I'm not sure that was the perfect answer to your question, Raymond. I think it's a good point. I don't think that was covered in the webinar, actually.
Thank you.
Unless you have an answer.
No. Well, the reason I asked the question is that I'm involved in a trial that is looking at whole body MRI and trying to use AI to speed up the process of identification of changes in bone metastases. And my concern about it is, if it comes up with a false negative, then somebody, for example, because we've trusted just AI rather than the traditional process, somebody's escaped the net, and they're out there. So that's what was behind the question.
Okay, so I think that's a very pertinent example. So that's entirely possible. So if you look at the way breast screening is a good example. So we've had breast screening in this country for many, many years. Mammograms are taken, and historically, the team would stick the mammograms up on a light box at the end of when they've been developed and look for abnormalities. And they could look at a particular mammogram and they may not spot something. So they may go back to the patient and say, no, sorry, you're all clear, when actually there was an abnormality in there which would have been picked up. So that's always happened. And the way you do that is with double and sometimes triple reading of those mammograms. Now, when digital imaging came in for mammography, the resolution became much finer. So you could spot things in much more resolution. You could color code certain things, and it became easier for the clinical teams to spot smaller abnormalities to miss less, but they still did double reading and they still do checks. Now you could say, well, we could also run alongside that a machine learning and artificial intelligence algorithm to do the same thing and run parallel to those clinical teams. That's largely how these things started to be tested out. And you could then say, did the algorithm spot what the clinical team spotted? And I guarantee if you look back through some of the literature, the algorithm may have spotted things which were abnormalities, which the clinical team didn't pick up because they were so small. So it can be advantageous. The problem comes when you rely on it and say, well, the machine says no, so you're okay. And that's the ethical question about where does those extra checks fit in? But it is entirely possible that computers and machine learning algorithms could spot things which the human eye may not spot. And again, that's just a general dilemma we're going to have. It's a trick. It's about that balance, but you have to put the checks in to make sure that you're not introducing false positives, which have always existed, but to make sure you're not making the position worse. It's a tricky one. Yeah.
Thank you.
And false negatives in particular, presumably.
Yes. Yeah. Did I say false positives?
Yeah.
Sorry, I meant false negatives. Sorry. Talking too much. With any other questions people have got about anything, even if it didn't make sense? No. In which case, 5 minutes to go. I get myself an extra cup of decaffeinated coffee. Thank you for the time. As I said before, all the sessions we do are things that people have requested, and we've got a list of things which we're going to be doing soon around. We're going to do a session on the National Disease Registration Service and how that works with our data, a session around population health, hopefully one with the Department of Health, and a couple of other things we've got lined up as well. We'll be sending notifications and dates out in the newsletter. Try and get a bit more advanced. Brenda.
Yeah, I just got a question which is probably come from what you were saying, but not related to particularly AI. You know these TREs where you're going to get the data?
Yep.
As I understand it, researchers have to say, I want this data, that, and the other data, without saying I want the whole GP record. Is that right?
Yes, that's correct.
So in a way, that's going to give better confidentiality, isn't it, to patients? Because the researcher has just got got to get that data rather than say, I want access to the GP record.
Yes. So a researcher has always had to go through that.
Have they?
Yeah. So a researcher can't just say, I want all the health data from all these people. Even if it was looking at bowel cancer, the researcher would have to say, I'm interested in patients who have had a diagnosis of bowel cancer within a particular group, within a particular age range, a particular time period. So there have always been constraints around the data for data minimization.
Sorry, that's not explaining myself. But I got the impression that once they got access, that once that patient has consented, once the selection has been done and that patient's consented, they get access to all of that person's data. Is that right?
So no, it's not. So
right.
If for a researcher to get access to all the patient's data is very rare, unless it's very highly consented rather than routinely collected data. The trusted research environment, this TRE, which is what you mentioned, is simply a secure platform in which you can let a researcher work and you can watch what they are doing. So it's quite safe. We've done some stuff on TRE. I just wonder whether it might be worth running a session on trusted research environments and what they actually mean and what they do. Okay.
Yeah.
I'll add that to my list then, Brenda. Okay. Raymond.
This is completely different question, really. It's a bit left field, but there is a system that looks at binary stars, and they try and identify from screenshots taken by, for example, the Hubble telescope, that tries to identify binary stars. And they found that the machines couldn't identify all of the stars, so they actually introduced a system where individuals could log in and they could look at screens and they could actually pinpoint what they thought were potentially binary stars and feed that back into the system. And tens of thousands of people got involved around the world and they identified these binary stars or potential binary stars. I just wonder where AI fits into that process. Is it because the machine has failed that we now go back to people, or is it because the machines that we had weren't good enough and that AI would now be able to predict where binary stars have been missed before?
That's a good example. So I suspect the answer you get from a technologist is that AI and machine learning gets better. So if it gets an answer wrong and you say, no, that answer's wrong, it says, oh, right, I need to go and learn why I got the answer wrong. So in theory, the machine learning should improve and improve and improve to match the performance of the humans and therefore overtake it. But yeah, I still think that's a really good example of where human intervention at scale can do what a computer algorithm could do by itself. But it's a scale thing. So if you've got 1,000 people involved in that, they're doing the work that one computer could do in half an hour. That's where some of the challenge is going to fit. We had this in the late 90s where there was SETI, Search for Extraterrestrial Intelligence, where large data files of audio noise recording from space were issued out to tens of thousands of people, and they just listened. I think that was where they listened for signals from aliens.
It's still out there.
Yeah, that was actually something around. That's probably more akin to federated analytics, which is maybe another topic we cover, where you take a particular complex problem, let everybody work on the problem at the same time, and bring the answers together. That was an early example of what they call federated analytics, but it hasn't worked yet so far.
Basically, could these machine solutions come up with a percentage confidence in what they say? So that they might say, yes, I'm 95% confidence without these positives and negatives, or that is a star, or I'm 60% confident that I've got it right.
Yeah, they do. In fact, that's how they work. That's how they get tweaked. And that's also been a principle of old style algorithms as well. The confidence, you'll see researchers have confidence intervals. The algorithms work on the same principle, that it's a level of confidence that I think it's this versus not this. So that's part of the way they work. Yeah.
Thank you.
Cool. Okay. Right. 2 minutes left. I hope that's been helpful. We'll get the recording up on the website and we'll put it on the newsletter when it's ready. You to rewatch if you want. Other people can watch it as well. So yeah, thank you for all your time. Got any other suggestions for topics, just send them through to me or Alison, or find us at any point. We're always happy to put more of these things on, always looking for subjects. But if that's all, have a lovely sunny day in Sheffield. A sunny day and a nice warm week, hopefully.
All right. Thanks very much, Chris.
Thank you all. Take care.
Right.
Thank you.
Thank you.
Bye.